So guys, I'm going to tell you a very important project what you can actually make during your BTech final year major project. Okay, you are watching this video from anywhere on this globe. This project is very important. You can make this if you have interest in aircraft propulsion. This project can be prepared by aeronautical engineer or aerospace engineer. All right. So I will discuss about the project proposal. So guys, this project is for your university level, and also in the last of the video I will tell you what will be the SOP statement of purpose when you will submit this project for your future higher studies like MTech, MS or PhD. So what kind of SOP should be there based on this project, so that also I will discuss. So let's understand the project idea. So this project idea I'm giving you, not the entire project. I will not tell you that exactly bit by bit, but almost everything roadmap, complete roadmap I'll give you. How will you prepare this project? So before entering to this, my name is Vikas Kumar Srivastav. I have completed uh, I'm running a dedicated coaching center for GATE Aerospace exam. I teach GATE Aerospace students, and I am an IITian. I have qualified GATE Aerospace exam 8 times, and I am an MS from IIT in Aerospace Engineering. So my research was in aerodynamics and propulsion. It was regarding the flow distortion. So I think I'm the right person to discuss projects. So this is the first time when I'm talking regarding a project in detail. So let's start. So your project proposal will be see, because this project I'm making public, so different students will be doing the project. Maybe today you are watching, and after 2 years someone else will be watching. So little bit modifications you guys can do, or whatever is the future possibilities regarding the extension of the project, that also I will mention. So see here, the project what I'm proposing is like design and performance analysis of a micro turbojet engine using CFD and thermodynamic modeling. So it is regarding complete turbojet engine, but a mini size turbojet engine. So this is regarding, I mean, here, this project is very important, very good project, because people who are having a very good interest, I'm not saying knowledge, I'm saying interest, so much interest in propulsion, aircraft propulsion, they can opt or they can go for similar project. Okay, let's go ahead. So what will be our objective in this project? So we will be designing the components of micro turbojet engines, and we have to evaluate its performance using combination of thermodynamic cycle analysis and CFD simulations. The aim to understand how component efficiencies and design parameters affect thrust, TSFC and thermal efficiency. Okay, so this image is just to make this little bit fancy, this PDF, just to avoid the boringness. Now what are the things you have to approach for this project? So you have to do CAD design of entire engine component. When you will do CAD design, then you will enhance yourself, you will explore lot of CAD. Actually you can use some softwares, I'll tell about them properly. So what you have to do, you have to do the designing of components like inlet can be a diffuser. Diffuser is also known as inlet. Compressor, combustor is also known as combustion chamber or burner, then turbine and nozzle. And you have to do 1D cycle analysis to estimate ideal and real performance parameters. That is also very easy to do. If you are preparing for GATE exam, or if you are having a very good background from your college itself, if you are from a very good college, that can be IIT, NIT or any very good college, if you appreciate your college and your professors, and then you can go for CFD simulation using ANSYS CFX or Fluent of flow through the combustor. I will suggest you go through CFX because I use SolidWorks and CFX and MATLAB for my works. So CFX is much better for Fluent wherever rotation and all comes into picture. Now CFD simulation, you have to use, in my way, I'm saying you can use ANSYS CFX, and flow through combustor and nozzle. For that also you do CFD simulation, and then thrust and TSFC estimation under different operating conditions. Then you have to prepare your final report, presentation, and poster. Poster is not important in every case, but you can if you are presenting that in your college poster programs. Now, what are the softwares you have to use? Let's discuss that. You have to use SolidWorks, CATIA, or Fusion 360, or any fancy softwares, or wherever you are handy, user-friendly software you can use. So, like, I feel good with SolidWorks, so I'm using Solid, because when I started CAD, I started with SolidWorks. Then ANSYS Fluent or ANSYS CFX. Most of the students are not aware of CFX, but guys, CFX is better than Fluent. Uh, when I see, in the beginning I was comfortable with Fluent, but my guide at IIT, he suggested me to go for CFX, because I also have done one project and paper also I have published based on, but I used CFX for safety simulation. Whenever you have rotating parts, or CFX it gives you more uh, more options. So maybe even those things you can do in Fluent also, if you are good at Fluent. But if you are just about to start, you start with CFX. In ANSYS, CFX is like a Fluent, another thing, but better I feel. So then you can go for MATLAB or Python for thermodynamic cycle calculations, and you can also use CoolProp for fluid property integration. That is optional. Now, in all these things, you see four different achievements you are having. You are learning a CAD software, because you have to do that. You have to do the modeling. Next thing, you are using ANSYS, so that is another achievement. That is additional value in your UG. And then MATLAB or Python, you are going good. And then you are using CoolProp. So even one kind of software. So let's discuss in what pattern you should go ahead. So guys, that I say as methodology, like in your project, what methodology you have used. So first you have to do literature survey. So these topics: study Brayton cycle, mini jet engines designs, and small turbine technologies. So go to Google Scholar, and these topics you download and you do literature survey of these people. Then you go for component design. So how much lengthy which component will be, what are the blades, number of blades, all those things you design. So you have to model axial compressor. One or two stage you can model. Then you have to do a combustor, that is nothing but a simple can. Then single stage turbine, there also only single stage, and a CD nozzle. Then you can also go for a normal nozzle, but CD nozzle is fine. Better you go for a normal nozzle. When I say normal nozzle, means only convergent nozzle. Then you go for thermodynamic modeling. You have to write your MATLAB code. That is very easy. Writing MATLAB code is not a tough job, because all those equations you are going to use here, so you have to sit. So you know what, I feel that if you will do all these segments day by day, then in every one day you can finish one task, and within I think 20 to 25 days this work will be done, if you are putting your sole effort every day. It's not like if you are just free for 1 hour or 2 hour, then this will cross 1 month or 45 days something. Okay, so then you have to do thermodynamic modeling. For that you can use MATLAB or Python code for ideal and real Brayton cycle simulations. And you know what is the fundamental background, like how to write pressure ratios, temperature ratios, how to find efficiencies. Those formulas you can use in this thing, MATLAB. Then you go for CFD setup. Here important facts are there. When I presented my paper in National Aerospace Propulsion Conference at IIT Madras, I used a CFD setup in ANSYS, and I used CFX. So you have to simulate the flow in the combustor with heat addition. So you know, when you will be choosing your CFD program, under that if you choose CFX or Fluent, anything, then you have to choose a model also. So also you have to run, you can see here, run nozzle flow for Mach number distribution and shock analysis and thrust output, right? So you have to use SST turbulence model, or you can use K epsilon model for stability. but SST turbulence model you can use, that is fine. Then you go for analysis. So you have to compare your CFD versus thermodynamic results, because thermodynamics results what you are getting through MATLAB code, that will be different, and what you are getting through CFD, you can compare those answers. And you can you can do analysis on the trends with varying pressure ratio and turbine inlet temperature, because turbine inlet temperature is very important part of the jet engine, because turbine inlet temperature will decide what will be the maximum temperature uh, of the hot gases, because beyond that, beyond certain limit, if you give fuel, then maximum temperature at the inlet of turbine and turbine blades will melt. So then expected outcomes, what we are expecting, we are trying to understand. So I have written here understanding of jet engine thermodynamics and CFD validation. Like you have a numerical value, like see how we solve any numerical in our gate class, in my coaching, or in your university classrooms. Like jet engine is flying at this altitude, so pressure ratio is this, that, find out efficiency, blah blah, find out thrust, inlet velocity, exit velocity. So like that, we have to validate those things using CFD validation also. And then exposure to industry tools, practical simulation challenges, because when you do simulation, when I did simulation, I remember there was one night when by mistake I copy pasted one of the model, and 40 times I was running my simulation using, actually total 120 times I had to run the simulation for different results for different cases, and 40 times I used a wrong mesh file. Meshing is there, right? When you do this, then you have to bring this to meshing, and that's what simulation challenges. And you know guys, at Btech itself, if you will do a very good quality project, let it reach to its best level, let it reach, don't, I mean, take help of your seniors, take help of your professor, and you can also text me in the video itself if you are willing to have some help. If I'll be having free time, I will definitely reply. And then if your report, if your work is really good, then you can publish a paper also. And publishing a paper in a journal or any conference will make a very huge difference, very huge impact for your MTech MS admission in other countries. Even you can reach to those colleges where right now you're not at all thinking. Okay, you may be aware that there are some countries, they accept even gate result, gate scorecard they accept. So third point I have mentioned here, publication worthy report or potential to present as a student symposium. Anyway, so this was interesting to know. Now some students, they can extend this work. Suppose in 1 year your senior did this project by seeing this video, then next year when your time comes, you can extend this project as optional. Like you can add afterburner between turbine and nozzle, and you can compare the result with afterburner and without afterburner. Now let's see some additional useful links I have given here. These links you can just take screenshot, copy paste using Google Lens, and directly you can use this. Okay, now open source on YouTube videos I have written here. And now it is about SOP. When you will finish this, then take the screenshot for this statement of purpose and use for your MTech MS or PhD admissions in further journey based on this project. This SOP is based on this project. Okay, so take the screenshot and just go to Google Lens and find out text and save somewhere. Alright, so I will just reduce the size so that you can take a screenshot properly. I hope this screenshot will come properly. This part you take a screenshot, and this was the beginning part, so I can zoom, take this part as a screenshot, take this part as a screenshot, and this part as a screenshot. That's all. Okay, so I will further, because I don't know how helpful this video will be, but now I will start giving you project ideas as well. This is the first video based on true project where you can give very good input. Thank you all.